Hi, I'm Steve Dinan, and today we're going to talk about Dinantronics, which is an electronic control unit to increase the boost and retune the engine for increased performance. What a control unit does, an aftermarket control unit does, is alter the signals into the factory ECU to basically make the ECU think that the engine is running a lower amount of boost so that you can get the car to raise the boost to the target that you would like. So it works essentially like this. Normally the engine runs 9 pounds of boost on a standard BMW, and we want to run 14. So what we do is we tell the computer that the engine's making 4 pounds of boost, so the computer then raises the boost back up to the 9 pounds it thinks it wants to make. So basically what we're doing is we're telling it it's low, so it raises it back up to its target. The problem with that is we now have fuel flow for 9 pounds of boost and we're running 14. We have ignition timing for 9 pounds of boost and we're running 14, so both are off. So we have to do some correction. The problem with most piggyback boxes on the market is all they do is raise the boost, by either modifying the manifold pressure sensor or the air mass meter, but they don't go in and correct for these variances in fuel mixture and ignition timing. They rely on the NOx sensor of the engine to do this correction for them. And then the engine doesn't run as smooth as it could and doesn't make as much power as it can. And the catalytic converter temperature is higher than it should be. So at Dinan, we modify a lot more signals. If you look at our wiring harness here, and you look at most aftermarket control units, there's just a few cables coming out. But we run 54 plug connectors, 4 of them. This is a V8 BMW, 2 from each ECU, so 216 wires through the box. This gives us the ability to process whatever we want to. And we modify the same manifold pressure sensor and the same air mass meter as everyone else to raise the boost, but then we go on top of that, to modify the wastegate signal to make sure it's in sync so we don't get a fault. And then we also program the oxygen sensor signal to the engine, as well as the fuel flow to the engine, so the target fuel mixture is correct, and the fuel flow is correct for the target mixture. This enables us to get much smoother performance, much better drivability.
So today we are here tuning a 228i with an electrical wastegate on our chassis dyno. What I like to do is start by characterizing the car, doing a baseline with the car completely stock. And I take a look at every single channel that I intend to modify. Air mass meter, pressure before the throttle body, pressure on the intake manifold, wastegate position signal, or in case of a mechanical wastegate, we would look at the actual duty cycle of the wastegate, characterize everything in several throttle increments, 50% throttle, 75% throttle, wide open throttle, and get the pressure readings from everything. And then we start skewing the signal slightly, say a 1/10 of a volt here based on RPM. Then I'll start doing my dyno runs, and then I'll also watch with our data logger that we built specifically for the Dinan ECU. I'll watch the signals going into the Dinan ECU and coming out of the Dinan ECU, number one, to see if the delta that I put in, that I programmed, is exactly what I'm getting. And then I'll also measure this on the dyno, and then I will see what delta in horsepower and torque that I get. And then that's sort of the mapping process that we begin with. Every signal will have a delta, so if I just skew the pressure sensor and make more boost, the wastegate will be in a different position. The air mass meter is going to read a different frequency. The short-term field trim is going to be in a different spot. So to compensate for it, this is what the Dinan ECU does better than, say, some of the other boxes that are out there. We will take all these other channels and translate them equally. Everything the factory ECU sees will be in line with what it saw before we touched anything with the Dinan ECU. So as a result, some of your drivability will be a lot better. Your gear shifts, you may not necessarily see the number on the dyno, but when you drive the car on the street, you'll feel a lot better response from the car, particularly during gear shifts, or just hard throttle drivability will be a lot better with our product because we spend all this extra time and research into it. Especially with all our racing experience, the knowledge we've collected from the dyno, engine dyno, all the data logging I do here on the chassis dyno, all the data logging I do on the street, all the verification and all the automated tools that we have is everything that is involved in the final making of the actual product that becomes the Dinantronics.